Advent of Code, day 5. A bunch of. Ooh, interesting. So we've got two groups. Mhm. Something like that. Many are fresh. Great. And these ranges are probably very big. Okay. Um, let's actually do that. Uh, alrighty. Oh, there it is. Oh, okay. So this is range merging. Okay. I've done literally this before. I have to remember how to do this. So I get my ranges. Yes. Yes, 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 yes. Okay. Okay. Oh man, I do not remember exactly how I did this. Uh, yeah, I don't remember how I did this last time. I'll look later. This approach would work, but I'm gonna split these instead because there's not that many. Um, yeah, there's not that many. So we do that. We look until Maybe this is easier to think through. Man. Mhm. Okay, this will be better. Answers that. So we've got A to B2 minus 1, and A2 plus 1. Rest, where's rest? I don't even need that. And you, I can just star so that you're A and B. Answer. Of course. Really? Can't be that degenerate. I'm doing something wrong. There we go. Whew. That shouldn't have taken me so long. Um, yeah. But I got it in the end. Yeah. It is an interesting problem. I'll be interested to see how long I should have taken to solve this. I don't even remember offhand. This reminds me of a previous problem. I think it was from 2022. Not that one. Not that. That's all moves. Cubes. I think it was this one. No, this is exterior surface. Okay, I don't remember offhand. There was a problem in a previous year where you had a bunch of ranges like this, but they were ranges in 3D space, and you ended up having to count how many cubes total there were. Was very interesting problem, and I ended up doing a weird combinatoric thing where uh, there was a perfectly valid way to handle it where you did splitting of those 3D cube ranges like we did here. Uh, I took a very different approach in that problem where I would count the entire cube and then negate out the overlaps. I don't remember exactly how that worked. It was I'll have to find that later. It was I remember I was very proud of that solution, and that's what I was trying to do here, but that's just overcomplicating it. I think it was useful there because they were 3D cubes, and splitting them up would be splitting into so many pieces. It was going to be an explosion. But here, that's overkill, and I just wasted time thinking about that. But yeah, I mean, in part one, we just have a bunch of numbers. We need to see if they fit in any range. That's just simple math. And the nice thing in Python is you can do a combined if check where two checks in the same condition. This is implicitly the same as if I did a less than equal to n and n less than equal to b. Just nice and compact, and we're just counting. Nice and simple. Part two, we have to deal with the fact that these can overlap. So, a much simpler approach, and what I obviously ultimately did, just take each candidate, go through and see is there any overlap with the remaining ranges. If not, count it. Great, it's unique, no overlap, carry on. If it does overlap, then we'll split to the left side and the right side across the overlap and cut out the overlap portion. I did accidentally have B2 here and A2 here initially, which meant I wasn't removing overlaps, I was adding overlaps. That is precisely not what I want to do. But yeah, I mean, once you cut out the overlaps, you then do have to, with this approach, add them back as parts to process. Uh, so the number of ranges you're dealing with can expand initially, but eventually you'll get to unique ranges with no overlaps, and you'll get the answer. Honestly, don't even need functions here. This was just easier for me to think through. But yeah, I mean, with all that, get the answer. Very big answer. This is exactly why I didn't try and brute force it like I did a few days ago, because that would have wasted even more time. But yeah, ask the problem, and I'll be back tomorrow.